Chapter 8.3a is trigonometric functions of any angle. And there is an 8.3b, but it doesn't really have a lesson, so this is pretty much the whole lesson for 8.3. So first of all, we're going to talk about reference angles. Let theta be an angle in standard position. That means that its vertex is on 0, 0. The reference angle for theta is the acute angle theta prime formed by the terminal side of theta and the x-axis. Okay, so that's kind of hard to understand. In so many words, or in other words, the reference angle is the angle of the terminal side, the one that moves, and the closest horizontal line. Okay, we're getting to the horizontal line as fast as we can. It is always positive. All right, because we don't care about the direction of this angle, we just care about the angle itself. So here's some examples, and this is in your book if you want to look at this. That's great. Okay, so we have this reference angle right here, or this theta. Here's our terminal side, okay? Our reference angle is just the angle that gets us to the x-axis the quickest. Okay, so this angle, it's an acute angle because it's going to be less than 90 degrees, and we just take it right here. So this way, it looks like we're overlapping a little bit, but that's okay because we just need to get to that x-axis quickly. Or I should say in the shortest distance, maybe. Okay, same thing with right here. So find the reference angle for theta equals 5 pi over 3, and then b. We'll do in just a second. So here is my unit circle, and I have a couple of options here. 5/3 pi is, well, 5/3. And if I think of, okay, this is pi, so if I divide this into 3 pieces, okay, then it is, I get halfway around. So you have to think about, when we're thinking about a third of the circle, we're thinking, since it goes around 2 pi times, it's like a piece of pizza with 6 pieces. And if I do 1, 2, 3, 4, 5 pieces, okay, here is my 5 pi over 3 angle. So that means that I need to find the reference angle, which is right here. And again, it's always positive. It doesn't matter what direction it's going. It's just an angle. So, okay. So if I have 5/3 pi, I need another third to get to 2 pi, right? If I take 2 pi and I subtract 5 pi over 3, 2 is the same thing as 6/3, or 6 pieces in my pizza, okay, minus the 5/3 pi is going to give me pi over 3. So that is my reference angle here. Now, another thing you could do is you could change this to degrees. These markers are terrible. Okay. We could change this to degrees, and if we do that, then sometimes it's a lot easier to see the reference angle. So 5 times 180 divided by 3 is 300. So this is not only 5 pi over 3, but it's also 300 degrees. Well, how many more degrees do I need to get all the way around? And that's to 360, and that's 60 degrees. But it was given to me in radians, so I have to switch it back to radians. And 60 goes into 183 times, which gives me my pi over 3, which is what I had. Okay, now we have theta is negative 130 degrees. So 130 degrees is probably about right here, and I'm going in a negative direction. So I need to know what this angle is right here. Now, as you can see, this whole piece goes around half the circle. So the whole piece is pi, or I'm sorry, 180 degrees, which is pi, but we're talking about degrees. Okay, 180 degrees. So if I have negative 130, so this is 130 degrees, how much more do I need to get to 180? Well, that's going to be 180 minus 130, because even though that's negative, this still is 130 degrees, which gives me 50 degrees. Okay, so here's a couple for you to try. Reference angles can be a little tricky. The best thing to do is to graph them or to draw a picture of the circle and kind of go from there. But let's have you pause your video now. Okay. All right, 3 pi over 5. So 3 pi over 5. This one's a little bit harder to think of because we're thinking of it in terms of fifths. So we would be dividing up this half circle into fifths. But 3/5 is just a little over half, right? Because 2.5 is half of 5. So 3 is a little bit more than half. So I'm going to say right here. Okay, so here is 3 pi over 5. And I need this piece right here. Well, this is going to be 3 pi over 5 plus my angle here is going to give me pi, my half circle. So if I subtract 3 pi over 5 from both sides, I am going to get x equals 2 pi over 5. And how did I get that? Well, 3/5 plus 2/5 gives me 5/5. Yeah, because this is 5/5. If I'm finding a common denominator, this is 5/5 minus 3/5 is 2/5. Okay, I'm going to have to not use that marker anymore. All right, and 230 degrees. Okay, 230 degrees is a little bit past 180, but not quite to 270. So it's going to be in here somewhere. And remember, my reference angle is trying to get to the x-axis the quickest. So even though I'm backtracking a little bit, this is my reference angle. So I've got 230 degrees minus 180 degrees is going to give me that little piece, which is 50 degrees. All right, we will move on in the next video.